Alright, now we want to talk about finding x-intercepts of a graph, which is where you find your zeros. One way to find your x-intercepts is to try to factor an equation. Unfortunately, if it doesn't factor, then what you're going to have to use is the quadratic formula to find your x-intercepts. Right? You find your quadratic formula, that's where you find your x values, so you're finding two of them. You could also use your graphing utility, which is known as a graphing calculator, to approximate your x-intercepts. Now this could help you when you are graphing your equation. So what we're going to do is we're also going to have to describe your graph. Now whenever you describe your graph, you don't just say it like opens up and it like opens down. It's a parabola. You need to talk about more than just the direction of your opening. You need to list your vertex, any reflections, horizontal and vertical shifts, and any stretches or shrinks that you may also have. All right, so let's look at our example here, number 3. The first thing we're going to do is we're going to rewrite this equation in standard form. So we need to complete the square. Complete the square. So if we complete the square, we're going to start off with our f of x equals negative x squared minus 4x plus 21. And we need to move the 21 to the left. So we're going to say f of x minus 21 equals, you're going to have a negative x squared minus 4x left over here. Now we are going to need to complete the square. So when we complete the square, we need to leave a little space here on the left because we're going to have to put some number, some value, some c value right here. And then we're going to have to factor out a negative 1. You can't complete the square unless there's a positive 1 in front of your x squared. So we're going to take out a negative 1. And when we do that, we have x squared plus 4x. So don't take out your negative 1 until you have just your x's. So what we need to do is we need to find our c value. So c is found by taking b divided by 2. So your b, this is your b, this is not your b, this is your b. You have 4 over 2, and you square that. So you get 4 divided by 2 is 2. 2 squared is a 4. So I'm going to put a 4 in here. I'm not going to put a 4 on the left side. I need to take 4 times negative 1. And what I need to do is I need to put a negative 4 right here. So what we're going to do is we're going to clean this up. And we're going to say we have, whoops, wrong color. Wrong color. Where's my eraser? Blue. We're going to say f of x minus 25 is equal to a negative 1. And then we can factor this trinomial into an x plus 2 squared. So now if we move the 25 to the right, you're going to have f of x equals negative 1 x plus 2 squared plus 25. So we need to describe our function. We're going to have to find some x-intercepts here also. So let's see, what can we do? Well, let's go ahead and describe this. So we have a vertex at negative 2, 25. So unfortunately for this graph, we don't go up 25 places, so we're going to have to do a little work here. We're going to go on your y-axis. We're going to go by 3s. We're going to estimate as much as possible. Your x-axis, we're still going to go by 1s. So your vertex you'd have at negative 2, 25. So I go back to up 25. So 3, 6, 9, 12, 15, 18, 21, 24, barely above there. There's our vertex. This opens down. It is shifted, so we have a shift left, left 2, and up 25. And we also need to say if we have any x-intercepts. So in order to find some x-intercepts, your x-intercepts we can find by factoring. In this case, we can find by factoring because we can actually factor this function up here. So if we start off with negative x squared minus 4x plus 21 equals 0. If you divide everything by -1, that's just going to change your signs. So that becomes x squared plus 4x minus 21 equals 0. And if you factor this, that gives you an x plus 7 times x minus 3 equals 0, which eventually, if you solve those, set each of those equal to 0, you get x equals -7 and a positive 3. So you do have a couple x-intercepts. You have one at -7, -1, -2, -3, -4, -5, -6, -7. We have one at 3, 1, 2, 3. You should probably find some other point in here. We don't have a stretch out here, so we know this is opening down. We have 3 points. You really should find some other points, but because we are sketching and don't have to be perfect for this example, here you go. Now how could you find other points? Well, you could either use what we did before. Since it's opening down, you could start at your vertex and you can go to the left one, down 1. Oh, hey, wait, no. To the right one, down 1. Oh, hey, wait, no. To the left 2. Whoops, sorry, that would have been. And then you find your other points. Or you can make a table. Whatever makes you feel better about yourself. So that is a long example of how to graph a quadratic by putting it in standard form and by describing it and finding any x-intercepts.